Okay, so moving back to the notes and page 65 of the notes. On page 65 of the notes, 65, we're looking at the graph of y equals cosine of x between 0 degrees and 360. It's very, very similar to what we did with sine, and as you saw from your homework last night. So if we go up in 45-degree steps or 30-degree steps, as was plotted here, you get these values for cosine of x when x is here. So our output is always the y value. So we get these points. We get the points 0, 1, 45, 0.7, etc., etc. We plot those points. 45 would actually be here. 45, 0.7, just to show that that is on the graph. And we have the same kind of smooth curve as we had described for sine of x. Let's fill in the radian values as well, just to remind us. Excuse me. We've got pi over 4, which is 45 degrees. We've pi over 2 for 90 degrees. We've pi for 180, right under here. And in between is 3 pi over 4. It's 3/4 of pi. Then, excuse me, we have 3 pi over 2, 1.5 pi's, and 2 pi, a full circle, and all the values in between, 5 pi over 4, and 7 pi over 4. So we should be able to map between our degrees and radians fairly quickly. It's okay to fill them both in on the x-axis if it makes it easier for you when you're drawing it. Excuse me. Let's look at the shape of the graph of cosine of x. Y equals cos x is how we write it because it's a function in the domain minus 720 to a plus 720. And what this represents is going around the circle 4 times. And I'm not going to do an input-output table for this. I just want to do a sketch, a very quick sketch. I'm not even going to use a ruler. I want you to get the idea of what's happening. I'm going between a +1 and a -1. And let's call this one full circle, 360 degrees, and 2 full circles, 720. One full circle this way, and another full circle that way. Okay, 180 degree chunks. And what happens is, we look back up here, cosine of x oscillates between 1 when it's 0 degrees and -1 when it's 180 degrees. So it's going between 1 and -1, 1 and -1. Oh no, I've gone a bit wrong there, sorry. 1 and -1, 1 and -1, and back up to 1 again. Just clear that mistake there. Okay, so every 180 degrees it goes between 1 and -1. 1, -1, 1, -1, and back up to 1. And it hits the 0 axis at the 90 degrees. So at 90 degrees it's 0. And every 90 degree mark, every 90 degrees plus 180 degrees, it's back at 0. So we have all these 0 intercepts on my axis. And when I sketch that, a little bit hard to see that now. We know though that we're following this shape. That's why I wanted to do this. I wanted to show the shape of cosine of x. So it's going up and down, oscillating between 1 and -1, going through the x-axis every 90 degrees. It's a little bit wobbly, but there's the idea of the shape. It looks just like sine of x. So cosine of x actually has the same graph as sine of x, but it's shifted by 90 degrees. And of course that makes sense because cos x is my x value on the unit circle. So remember our unit circle like this. Imagine a point going around. My point starts at 1. Starts at 1, down to 0, minus 1, 0. So I'm just looking at what's happening to the x values going back and forth here. I'm going to pop, so this is y equals cos x. I'm going to pop a quick graph of sine of x underneath it so you can compare it. So the x and y axis are at 90 degree angles from each other, which is why cos and sine are shifted by 90 degrees to each other. So again, I'm going to go up as far as 1 and down as far as minus 1. And it's going every 180 degrees. There's 360, there's 720. I wanted to line up with it so you can see them in the same place. Minus 360, minus 720. I'll fill in the 180 degrees. So sine, excuse me, the y value on my unit circle, I start at 0 degrees, the y value starts at 0, goes up to 1 and then down. So remember, sine starts at 0 and then goes up to 1. Then it's back down to 0 and then it's down to minus 1 and back up to 0. Down to minus 1, back up to 0, up to minus 1, back down to 0. And we have 90 degrees in between as well. So let me just double check. I'm after going wrong with this. I jumped the gun a bit. It's sine of 90 degrees is 1. And we're back on the 0 axis every 180 degrees for sine. That's what happens when I try and skip steps. So every 90 degrees, sine oscillates between 1 and minus 1. So whenever cosine is 0, sine is either 1 or minus 1. Here's my 90 degrees here. Back down at minus 1, up to 1, down to minus 1, up to 1. And really what I'm interested in is showing that the shape of these two graphs is identical up and down, up and down, up and down between 1 and minus 1 as we go round and round circles. If you just look at the bit in the middle, my 3 waves there, this is moved over by 90 degrees and it's exactly the same shape. Okay, so we'll just make a couple of notes there and just say that when cos of x is equal to 0, sine of x is either equal to 1 or minus 1. The absolute value of it is 1. And when sine of x is equal to 0, cos of x is equal to 1 or minus 1. So they're identical graphs, just shifted over. Now, using the graph to find values, we went through in the homework video, so I'm not going to go through it again here. We'll have some more homework questions like these, and we can practice with that. Okay, I do want to look at the graph of tan of x, and it doesn't look anything like the previous two that we've had. So the first thing to note is that if we remember the definition of tan of x is that it is sine of x divided by cosine of x. That's the definition of tan of x. It's the slope of the tangent to the radius at a given point. It's easier to just remember it like this. So it's rise over run. It's the y value divided by the cosine value. What does that mean? Well, whenever cosine of x is equal to 0, tan of x gets a divide by 0 error, is undefined. And we remember that cosine of x is equal to 0 every 90 degrees. Okay, so every 90 degrees, then plus 180, and plus another 180, and plus 180. So starting at 90 degrees, plus or minus 180 in either direction. That's what's going on there. So if we look at 90 degrees, and actually fill in infinity. Infinity and undefined mean the same thing. What happens is when you divide by 0, the value shoots off to infinity. And the closer we get to these values, the closer we get to cos of x equal to 0, the bigger the value of tan. The bigger the value of tan of x gets. Okay, so again, plotting the graph of this, it's the same as what we've done before. We're looking at tan of x here between minus 90 and plus 150 for this input-output table, and you can just put the values into your calculator. Now, what happens if you put in tan of x, tan of negative 90? We get a math error. Okay, and first of all, you might think, oh, maybe I put in the minus sign wrong. That's not. It's because tan is undefined at 90 degrees and every 180 degrees after that. So tan is undefined, at 90 degrees and every 180 degrees after that, in either direction. Now that's pretty much all you need to know about the graph of tan of x. So it has a completely different shape to sine and cosine. Sine and cosine being these lovely wave shapes. Tan of x, I guess it's a wave, but it looks like kind of a skewed thing here. These green lines, these have a special name. They're called asymptotes. And when we do functions next, you're going to learn a bit more about them. Let's fill it in here. They're asymptotes. An asymptote is a value that a function or a graph, in this case, can come infinitely close to, but never ever reach it. But never reach it. So what do I mean by that? So I said that tan of 90 degrees is undefined, but tan of 89.99 degrees is defined. It's a pretty big number. And actually, the closer I get, it shoots up really quickly. So it's nearly 60,000 when I've got 3 nines. It's nearly 600,000 when I have 4 nines. Nearly 6 million with 5 nines, and so on. So it's going up by a factor of 10 every time there. You can see it's getting really, really big, really quickly. So it doesn't matter how many nines I fill in here, however many my calculator will take. The calculator just ran out of space there, so it rounded it to 90 degrees and then it gave me the math error. But we can theoretically come infinitely close, 89.99999, however many times we want, so long as we don't actually reach 90 degrees. And that value, when x is equal to 90 degrees, is called an asymptote. And of course, x equal to 270 and x equal to minus 90. Those are all asymptotes for tan of x that it can never reach. So that's where I want to stop today and practice drawing those. I'm going to put up some homework in Google Classroom for you to practice a little bit more with the graphs of sine, cos and tan. And then we're going to look at what happens when we multiply the angle or multiply the function and what effects that has on the graphs as well. Okay, thank you.